Are we now facing the end of the Big Bang Theory as we know it? Following a baffling discovery by the James Webb Space Telescope, Michio Kaku acknowledges that we may need to revise our astronomy textbooks and to re-examine long-held beliefs about the universe's origin. In fact, Webb has now identified a series of puzzling structures that shouldn't exist in their current form, challenging everything we thought we understood about the evolution of the cosmos. So what exactly are these strange and unexpected findings? And if the Big Bang wasn't the starting point, then how might the universe have truly begun? Stay with us as we explore what Michio Kaku has to say about these astonishing discoveries from the Webb telescope. The hopes and ambitions launched into space on December 25, 2021, along with the James Webb Space Telescope, are nearly impossible. To put into words, more than 10,000 individuals contributed to the creation of this groundbreaking observatory. The project took over 20 years, cost around $10 billion, and required tremendous effort and perseverance before it was finally realized. International collaboration from NASA, ESA, and CSA brought this ambitious scientific vision to life as the successor to both the Hubble and Spitze telescopes. When the first images were released in July 2022, they offered a striking demonstration of what had been promised: the most powerful space telescope to date. Webb was specifically designed for infrared astronomy and is up to 100 times more sensitive to electromagnetic waves than Hubble. Theoretically, it could even detect the heat signature of a bumblebee on the moon's surface from Earth. In practical terms, Webb is being used to observe galaxies, stars, and black holes, advancing our understanding of how cosmic structures form. It's also examining exoplanets for signs of habitability and is helping to uncover the earliest luminous objects formed after the Big Bang during the so-called Dark Ages. But what happens when we come across something that, according to our existing models, shouldn't exist at all? When a discovery is so bewildering that even seasoned experts call it impossible? In such a case, turning to a physicist like Michio Kaku is a logical step. It's essential to keep in mind that the James Webb Telescope is, in essence, a kind of optical time machine. Because light from distant celestial bodies takes time to reach us, we see these objects as they appeared in the distant past, and we mean very distant. The 6 reddish objects that Webb discovered in February 2023 existed when the universe was only 500 to 700 million years old. For perspective, current scientific consensus holds that the universe was born about 13.8 billion years ago. Our own solar system formed roughly 4.5 billion years ago. So how is it that 6 seemingly simple points of light are shaking the very foundations of cosmology and earning the nickname universe breakers? The reason is that these aren't just ordinary points of light, they are extremely early galaxies that appear to be far more massive than current models allow. So, who or what is mistaken? The models or the universe itself? With that question, more inevitably follow: is it possible that galaxies formed in a completely different way than we thought? Have we missed a critical piece of the cosmic puzzle? Could the universe be much older than previously believed? Did the universe perhaps not originate from a Big Bang at all? The James Webb Telescope is challenging long-held assumptions. Let's look at what Michio Kaku had to say in an interview with NBC News shortly after these discoveries were made. He didn't mince words. The James Webb Telescope is turning everything upside down. Suddenly we realize that we may have to rewrite all our textbooks on the beginning of the universe. It takes many billions of years to form a galaxy. But the James Webb Telescope has identified 6 galaxies that existed just 500 million years after the Big Bang, and even then, these galaxies were up to 10 times larger than our Milky Way. That simply shouldn't be possible. There shouldn't be any original galaxies larger than the Milky Way and only 500 million years old. Something is wrong here. Maybe we need to revise our theories about the origin of the universe to understand the gravity of Kaku's statement. Recall that nearly all current cosmological models suggest that shortly after the Big Bang, there wasn't enough ordinary matter to form such large galaxies. Researchers expected to find only small, early-stage galaxies from that era, but Webb found something entirely different. Initially, scientists suspected there might have been an error in the data. But when no mistake could be identified, the mystery only grew. So, what does all this mean? Is the universe far older than we've assumed? Or could these supposed galaxies be something else entirely, perhaps a kind of cosmic illusion? The NBC reporter raised exactly that question. In response, Kaku said, "Some people say it's an optical illusion. According to Einstein, gravity can act like a lens, much like how glass works in a magnifying glass. In astronomy, we call this effect gravitational lensing. It can make galaxies appear far larger than they actually are. So what we might be seeing are not enormous galaxies, but much smaller ones that look larger due to this lensing effect." However, Kaku went on to offer another explanation. "I personally believe they are not baby galaxies at all. I think they're actually gigantic black holes that formed very shortly after galaxies began to form. And that's what's baffling. It doesn't fit our current understanding of how galaxies form. I think what we are witnessing here are enormous black holes, and new laws of physics may be needed to explain them. Anyone who cracks this mystery is sure to win a Nobel Prize." And indeed, Kaku's hypothesis seems to have gained support. A few months later, a team led by Dale Kachevsky from Colby College in Waterville, Maine, concluded that most of these reddish points showed signs of rapid motion characteristic of accretion disks around black holes, since the light primarily comes from these voracious black holes and not stars. Astronomers no longer need to invoke impossibly high amounts of matter to explain their brightness. But does this mean the crisis is over? Can we now return to our established models? Not quite. These universe breakers were only the beginning. Webb has since revealed even more phenomena that defy our theories, such as unexpectedly massive early black holes, heavy elements present too soon after the universe's formation, and entire galaxies that seem far too developed for their age just a few 100 million years after the Big Bang. So, is it time to retire the Big Bang theory? If we assume that the core issues identified by Webb are real and not errors, and that the universe didn't begin with a singular Big Bang, then what alternatives could there be? One possibility is that the Big Bang never happened and that the universe has existed forever. This idea, while counterintuitive to our everyday sense of beginnings and endings, suggests that the cosmos has always been there. Some versions of this theory propose that matter is continually forming, giving only the illusion of an expanding universe. Another idea is eternal inflation. This model still includes a rapid expansion moment like the Big Bang, but claims that this inflation has been happening forever. Only in small, bubble-like regions does it stop giving rise to individual subuniverses. These regions may even have different physical laws and constants. The Big Bounce theory takes yet another approach. It suggests that the universe undergoes endless cycles of expansion and collapse. After one cosmos ends in a big crunch, a new one begins, continuing the cycle forever. And finally, perhaps the most radical theory challenges the very existence of the universe itself. Based on ideas from quantum physics and string theory, this hypothesis argues that our universe might be a flat hologram projected onto a spherical surface. That is, we might all be part of a simulation. Well, it sounds like science fiction. It's compatible with the so-called Kardashev scale system that ranks civilizations based on their energy usage. A Type 3 civilization, capable of harnessing the full energy of a galaxy, might construct a system complex enough to simulate an entire universe, making us unaware participants in a false reality. Regardless of which model proves true, one thing is certain: discoveries made by the James Webb Space Telescope have challenged our most fundamental assumptions and opened the door to revolutionary new thinking about the cosmos.